This is a demo of how Hyperledger Indy can be used to support data sharing with consent, and specifically how users can use Hyperledger Indy to allow access or to provide access to data that's being held on their behalf by another party. And the applicability of this is things like medical records, where it may not be possible or practical to hold medical records on a user-controlled device, so they might be held at a hospital or a medical facility, or there might be some central repository where the data is required to be held for other reasons. For example, one of the reasons would be immunization data, where it's a public health repository where they use the data for things like managing and tracking outbreaks, and so forth. So this is an example using a Django-based framework. And we'll go through first of all, we'll go through the business process flow and then the demo of the application. And then finally, we'll look at some of the code behind the scenes. So this scenario is kind of a contrived scenario, but a parent wants to register their child in a school, and the school needs to validate the student's immunization status before they're allowed to enter. Immunizations are held within an immunizations repository by a health authority or public health body. So the school needs to ask the health authority for that record, but they need to do it with the parent's consent. So the parent provides the consent, and then that allows the school to get that information. And the way the flow of data works is, first of all, in this scenario, the health authority issues a health ID to the parent, as well as an immunization status, which goes in the immunization repository. Now, the health ID is kept in the parent's private wallet, and it allows them to identify themselves or prove their identity. So when the parent needs to register their child at the school, then the first step is that the school issues a health ID proof request to the parent, so the parent can prove their identity. The parent responds with a health ID proof. And then the next step, when the school receives this, automatically it fires off a consent credential to the parent, or a consent enablement credential, because it's the credential that enables consent. It's not the consent itself. As well as they send the health authority a proof request for the student's immunization status. When the health authority receives it, they don't act on it right away. They send a consent proof request to the parent to validate that the parent is allowing this school to access this data. The parent can then provide a proof which combines their identity, their proof of identity, along with the consent for the data that the school has asked for. The school provides their criteria within the consent, and then the parent, by providing that within a proof, demonstrates that they're consenting to that particular request. And then once the health authority receives that, then the health authority can respond to the school and send the immunization proof. Let's see how that works in a Hyperledger Indy scenario. So first of all, we've got the different roles running in 3 different browsers. So I've got Faber Secondary School, which has a connection to the health authority, as well as Bob, the parent. We've got the health authority, which has, first of all, it's got a connection to itself so that it can self-issue the immunization credentials, as well as it's got connections to Faber Secondary School and Bob. And then finally, Bob, the parent, has his connections to the health authority and Faber Secondary School. So to start out with, the first step is that the health authority issues the credentials. So we've got a custom screen for that, where we say issue credentials. We provide the name, Bob Smith. Bob's birthday is 1964. And health ID is 125. Bob's an adult, so it's an adult health ID type, and it was issued in 2010. Bob's immunization status is okay, and that was also issued in 2010. We'll submit that. Okay, and then right away we'll go and we'll issue a new identity for the child. So the child is Billy Smith, and Billy's birthday is 2001. And health ID 56789. Billy has a child health ID, so we want to tag the parent's health ID to that, so we know who is responsible. Issued also in 2010. And health ID is okay, issued in 2019. So we can issue those two credentials. So what happens when we issue the credentials? If we look here, it gives us a nice summary to say that it's sent a health ID credential and an immunization credential. The immunization credentials automatically get accepted by the immunization repository, but the health ID credentials have to be accepted by Bob. So we can come into Bob, he sees the credentials, he accepts them, and then eventually they will show up in his wallet. Oops. Just a quick note on the screens. This application managed data is a custom screen that's customized for each role. And after the demo, when we get into the code, I'll show how that's done. And if we come back here, we see that all the credentials have been sent. This was being sent. It can be accepted. Okay, so now the credentials, the health authority has the immunization certificates credentials in their wallet. And Bob now has his health ID. So he's got his own health ID as well as a health ID for the child. So the next step, what's the next step? The next step is that Bob wants to enroll his son into the school. So the school says, okay, well, first of all, we need to verify your son's immunization status. Parent's name is Bob Smith. Child's name is Billy Smith. And we'll send a proof request. And the proof request is asking for proof of a health ID so that when the school sends the proof request to the health authority for the immunization status, it's got the right identities in it. And like I said, it's a bit of a contrived example, but it's just showing the technical flow. That's a proof request that gets sent to Bob. So Bob now has this proof request from Faber Secondary School. And there's two credentials, and what we want is the son's credential. So we have to make sure to select the credential that we want to apply to each claim is Billy Smith, the son. There is a way to filter this within Hyperledger Indy, within proofs. You can filter by claim attribute values, but we're using the VCX agent, and the VCX agent doesn't support that yet. So the demo looks a little bit more complicated than it needs to. Anyway, we've sent now the proof back to Faber Secondary School. If we go back to Faber Secondary School and we check the status, we see that the proof has been accepted. And we've now sent two things. We've sent a consent enablement credential to Bob, as well as we've sent the immunization status to the school, or the health authority. If we pop over to the health authority, we'll see that we've received the health ID 56789. We've received a pending request, immunization status request, but we haven't responded to it yet. Instead, we've sent a consent request to Bob. And now Bob has two things that he's received. Bob has received an offer for a credential, which is the consent enablement credential, as well as a proof request, which is going to ask for proof of consent. So we first need to accept the credential. The consent credential is from Faber Secondary School. The name has a bunch of metadata just to tie the different messages together in a conversation. And the request is that we want to consent to release the child immunization status to the school. There's a bunch of information about we want it for 5 days, we want to view the status, and this is the information of the person that we want. Consenting health ID is the parent's health ID, and the person that we want is Billy Smith. So we can accept that offer, and then eventually that credential will show up in our wallet. So we'll just wait for that and take a, oh, there it is already. So we now have the immunization consent enablement credential. Now when we go back and take a look at the proof of immunization consent, there's going to be a bunch of stuff that shows up here. So there's two sets of data in here that are kind of muddled, but you can forgive the UI. This is a technical document or a technical demonstration. So first of all, there's the consent. So there's one consent record. So we need to apply that to each of the consent attributes. So that's the consent, and those are all the, they're asking for consent data, time to live, consent type, and so forth. And then the other one is the health ID. We need to map it to the health ID, and again, we need to map it to Billy's health ID record, because Billy's health ID is the one we want, and it is linked to the parent's health ID. It asks us for some comments. That's just a free text that Hyperledger Indy supports in a proof. It's called a self-attested attribute, but it just allows us to type in some free-form text just to prove that we know what we're doing, and then we submit that. So that proof goes back to the school or the health authority now. And when we go back to the health authority and we take a look at their status, we see that the consent request is accepted. The health ID status was accepted. That means the proof has gone back to Favor School. And then when we go back to Favor School, we see that everything is being accepted. And if we drill down into the conversations, the actual consent or the actual immunization status came from Island Health Authority as a proof. Here's the proof. You can see somewhere in here that is verified. And if we like, we can take out our calculators and verify all the cryptographic math. Anyway, somewhere in here it says verified. So that covered our flow. So there was a couple of manual requests. The school manually kicks it off. The parent, Bob Smith in this case, manually responds. And then once that happens, there's a few things that happen automatically. And then the parent, Bob, again, has to manually respond to the consent request. And then the status can be sent back to the school. So that's UMA in a nutshell. So how does all that work? So first of all, we've got two shells running. We're running a local Vaughan network, in this case, a local Indy network, which is the BCGov Vaughan network. And then we're running the Django Docker containers to run the Indy example. So that's all kicked off with the Docker compose script. And the environment is initialized with a bunch of scripts. Init ims.sh runs some of the Python admin tasks to load the organizations and schemas. So that's an environment initialization for us. And then we plug the environment in. We've got the Indy community package, which is the base platform, and then IMS demo URLs, which are some of the custom screens that we've added. In the settings, we see that we've got the basic VCX stuff. So the application, the core application is configured by adding the Indy community Indy core config to the installed apps, and then the Indy IMS demo is the extension that is specific for this demo. We've got some VCX agent configuration, and in this case, we're extending the profile by some custom views. That's the data, application data screen is linked to these views. And then we've got some callbacks that handle some of the automated tasks. So it's event driven in that when connection event or conversation event is received, then these callbacks automatically get called. So that's how we handle some of the automated processing. And then you can extend some of the models as well. We don't in this case, but if we wanted custom organization, custom relationship capabilities, then we could add that by configuring our own model and extending the Indy community model. We've got some custom models that we've added that are application specific. For the school to keep track of conversations, that's because there's multiple message flows that are linked. An initial proof request is linked to the subsequent proof request. For the repository, they have to remember that there's two proof requests that are linked, the one from the school as well as the one that goes out to the parent. Likewise, on the user side, this one isn't really implemented because the user flow is intended eventually to happen through a mobile device. And then there's a couple of tables just for keeping track of the health authority to keep track of what it's issued. So when it issues a health identity credential or immunization status certificate. It keeps track of it, and it keeps a link to the conversation so that it knows the status of whether that credential is accepted or not. As well as if the credential needs to be updated or revoked, then we've got a link to the original data. And this is going to be typical for systems that interface with Hyperledger Indy. They keep all the business data, and then they package a credential and send it off, but they still need to have the business data for themselves. For the views, we'll just quickly run through. There's our custom view for the mobile connection. These views are the custom plugins. So for the data view, there's custom view for a health authority, for a school, and for IMS repository, as well as the user. And then the data view, which is the one that actually gets called from the framework, dispatches based on the role type. So once that happens, we've got some custom views that are linked from those screens for issuing credentials. When the health authority issues credentials, we issue them in pairs, the ID as well as the immunization. And we also keep our own record of those when we issue them. And then when the school requests a health ID, it's got some custom logic around how it does that. And it keeps some metadata. It builds a metadata structure that it keeps in the proof name just so that some information can be passed from one step in the process to the next. So the automatic processing, we'll just actually skip down to the bottom. So there's callbacks that are called from the framework, one for connection events and then one for conversation events. The conversation events are dispatched from a table. So based on the role and the message type, they get dispatched to a specific message or a specific function that handles those. So we'll just go through those quickly, very high level. So first one is for the school when it sends a proof request to the parent, and when it receives the proof back from the parent with the health ID, then it automatically triggers a proof request that goes to the health authority. So that's this first one. The second one, the repository will automatically accept credential offers. So this is the case where the repository is accepting immunization status certificates from itself. And the repository auto-answering proof requests. So there's two scenarios with the repository. It receives a proof request from the school and automatically sends a proof request to the parent. And then the second one, when it receives the proof response back from the parent, then it automatically responds to the school. So those are two automatic functions. And then there's a couple around the repository and the user. It's more on the user side for updating some local tables. And as I mentioned, the intent of the user functionality is to move that eventually to a mobile wallet. So the local database tables won't really apply in that case. So that's a quick overview of how all of that is done. And the demo comes from the Indy Community Demo GitHub repo, and it's on a branch called IMS Demo. Thank you.